Awesome, thank you. So let's go ahead and get started. I'm going to give a high overview for folks that have no idea what Cluster API is. My goal is that you guys will walk out of here and understand how to create a cluster or just how it like works from a high level. Basically creating a bunch of clusters from Cluster API, but let's go through it. So here are a couple of questions that I really think exemplify this problem space that we're in today. And especially when we're looking within Azure, these are the kinds of questions that we're looking to answer with Cluster API, specifically the provider for Azure. And I think all the providers also target the space. So how do users manage the lifecycle of fleets of Kubernetes clusters running in the cloud? So we're not even, or just like on-prem, et cetera. We're not even talking about now just how do you manage the lifecycle of one cluster? Now the question is, how do you manage the lifecycle of hundreds of clusters at the same time? So we're continuously treating these clusters as cattle instead of pets. That's a common analogy used, I think, in this space too. So how do users easily deploy multi-cloud solutions across all cloud providers? So the API gives you basically a declarative, just easy way to understand how to deploy to any cloud without needing to know the necessary details per provider, which is really great. So this abstraction will help folks trying to get into that multi-cloud space. And then how do users build out tuned Kubernetes clusters for their specific needs? Of course, you can go within Kubernetes, and I mean, if you want to change specific flags or configurations within Kubernetes itself, you can do that here. But if you want to create tuned images, for example, if you want to create more tuning in terms of how you're creating these clusters and the rate you're creating these clusters and the way your clusters look like, et cetera, at a larger scale, Cluster API allows you to do that too. Within Azure, we also have a project that tackled this space more at the per cluster level. It was called AKS Engine, but we also believe that Cluster API will be a great project within that same space too. All right, so the design. So at a high level, if you guys haven't read the README yet, Cluster API is a Kubernetes project to bring declarative Kubernetes style APIs to cluster creation, configuration, and management. So provides optional added functionality on top of core Kubernetes. So that's exactly what it does. If you know how to use Kubernetes, Cluster API is very intuitive in its design because you're inherently just working with Kubernetes to manage all your clusters as resources within a cluster. That makes sense. So this is what your management cluster looks like. We're not going to go through all the details of this, but basically we're going to be looking at how to create this management cluster, and then from this management cluster, spin out a provider, and then from that, spin out worker clusters from that provider. So there's a bunch of different target clusters that you can have. There's a provider for Google. There's one for Amazon, Azure, VMware, and of course, like if you want to do on-prem workloads, you can do that too. So that's a high-level design. For you to get started with Cluster API, you basically start with provisioning a management cluster, or you can use an existing cluster. So you can use a kind cluster, you can use an existing management cluster within a cloud provider, you can use a cluster that you created on your own VM, for example, or a set of VMs. You then initialize that management cluster with cluster Cuddle init. So that makes it a management cluster and installs the necessary components for it to be a management cluster. You then run cluster Cuddle config cluster. So this creates this template or configuration for your workload cluster. You can go ahead and edit it, but this is an easy way to get started. From there, you use that template that you pipe to apply that workload cluster to your management cluster. So again, we're using like this descriptive configuration format to basically create these workload clusters from Kubernetes, which is really interesting. You can go ahead, access the workload cluster. A couple of other useful cluster Cuddle commands. So cluster Cuddle is basically our way of interacting with these clusters. It's cluster API's own CLI. You can use cluster Cuddle move to actually change the management clusters. So if you're using a kind cluster, for example, and you want something that's a little lifelong, you can change it to be like an AKS cluster, for example, in Azure. You can also upgrade your clusters and install new versions of the provider components. You can delete the provider components from your management cluster with cluster Cuddle delete too. And a little bit of what the future will look like. So we've already had some users kind of messing around with what Flux and Cluster API looks like, but this is taken from WeForks, by the way. But basically in the future, where ideally you'll be able to manage cluster definitions through a GitHub, GitOps style repo, and you'll do the same. So these are kinds of like the 3 different repos that you could have to manage the different parts of the lifecycle of your infrastructure, which is really interesting. So hopefully in the future we'll have more to demo on that. But I also am going to show a quick, hopefully 5-minute demo on how to create these clusters, create a management cluster, create these workload clusters. So let's go through that. I'm going to stop sharing really quick and share my next screen. And feel free to cut me off if we need to to change, Gianluca. Feel free. It should be good. Okay. So while this is starting up, it's a video, by the way, so it's a little bit easier for me to talk. I'm using a AKS cluster as my management cluster. So I've already created an AKS cluster. I'm grabbing those credentials down. I'm merging that kube config into my local context, making sure I can access that cluster. So this is my AKS cluster. I have 2 agent nodes within that cluster itself. Here's my cluster Cuddle version. Just wanted to spit that out really quick. And now I'm going to use cluster Cuddle init like we talked about before to actually initialize my management cluster. So create that AKS cluster and make sure that it can be a management cluster for Cluster API. I'm initializing it with infrastructure Azure, but you could do the same thing with Amazon, VMware, et cetera, Google, any other provider that you want to spin out workload clusters from. You can even have a management cluster have multiple providers. So you can actually spin out multiple kinds of workload clusters from the same management cluster. So that's also an interesting scenario for some people. Yeah, so we're just gonna fast forward a little bit while this provisions itself. So it goes ahead, creates that control plane, et cetera. Okay, so now that we have that management cluster created, well, and the management cluster is initialized, we can now go and create a workload cluster. So this will spin out to Azure, or reach out to Azure and actually create these workload clusters off of it. So again, we're gonna use cluster Cuddle config to get that configuration. I'm spinning it out to capi quickstart.yaml. And then I'm going to go ahead and kubectl apply that to my cluster. So we can see that command right here. And then once I do that, we will start provisioning. So I'm going to be creating a control plane and an agent node off of that. And that's all going to be spun out in Azure through VMs. So we're just kind of waiting for that to spin out. I'm going to fast forward it for the sake of some time. Okay, cool. And then you can use kubectl get cluster to see your clusters. And so that's a resource that you can now look out to see what's going on if you have multiple clusters, et cetera. And if you want to perform large scale operations across multiple clusters. They're just resources now within Kubernetes, which is a super interesting concept. I think another way to describe this is you're essentially creating a way for you to create services that we create within clusters. So this, you basically manage it through Kubernetes. You manage Kubernetes resources through Kubernetes workloads or clusters through Kubernetes. So that's how we do it. And so I think it's really awesome that now we can open source technology like this so anyone can create these large scale clusters and manage them. My Calico config. And so now I have CNI created. And from there, I'm going to grab my workload kube config and check out my cluster. So my control plane is not ready. My agent node is not ready yet, and that's okay. We're just waiting for that to come up. Fast forwarding a little bit. Okay, so I'm going to show you what it looks like in Azure. So within Azure, this is the workload cluster I just created. It's spun out a VNet, it's spun out multiple VMs, et cetera. And then I'm going to show you my AKS management cluster. So this is my AKS management cluster. You don't see any of the resources, of course, because we manage all of that for you. So yeah, that's what it looks like in Azure. And then we're going to go quickly back to grab the nodes now they're ready. So my workload cluster is now provisioned off of my management cluster. And really quickly, I'm going to show you how you could create a machine pool. It's a new feature that we've added within Cluster API and CADZ, which is the quick way to talk about Cluster API provider Azure, all the lingo. So again, we're just going to use cluster Cuddle config to create that config. We use something called flavors to basically describe what a machine pool is. So I'm going to -- flavor machine pool. And then I'll have a YAML file that describes the configuration for a cluster, a workload cluster with a machine pool within it. And that's where I end. So thank you all for listening. I'm going to pass it over to Gianluca. And if you guys have any questions, I think we'll have a little bit of time at the end.
Yeah, thank you, Ria, for the explanation for the demo. So I hope that all the people that don't know about Cluster API or didn't see it in action now know it, because I'm just have a black screen for you. So that's the best you're gonna get out from me today. And so the Q&A is open on Zoom, so feel free to leave any question there or in the track one on Slack, because that's where we pick them up. And yeah, we will definitely have some time later. So this is the project that is a provider for a cluster API. So every cloud provider has its own. And this is one of the reasons about why Kubernetes is so powerful, because it has a friendly API for like above users that are interacting with Kubernetes itself, but it also provides a lot of hooks that providers can use to serve their needs and customize Kubernetes itself. Even if it is a runtime or it is a CNI plugin or a storage, whatever, you can always hook them to Kubernetes. And that's probably why every provider is serving it. We saw the Azure one running. I'm going to show you the code, hoping for you to have a little bit of understanding about how stuff works. So when you do when you create a init cluster, you get something that is like a YAML, because that's how we pilot Kubernetes. So the one that we have for Packet, but it's like similar for the other cloud providers, looks like this one. Cluster API use a provisioner that is the strategy that you can use to join the cluster. And by default, it uses kubeadmin. So as you can see, I'm supposing that we are using an Ubuntu server here. So I'm using apt to install a bunch of needed program like containerd, Docker, and kubeadmin Kubernetes itself. And as you can see, like the field is kubeadmin commands. So those stuff are the command that runs before like kubectl join, kubeadmin join, or kubeadmin init, based on if you are in master or if you are in a worker. And there are commands for the after kubeadmin command. So in my case, I'm installing the CCM, so the cloud provider for Packet implementation, because it's not in the core of Kubernetes. And I'm installing the secret for that. But in there, you can also install like the CNI plugins or whatever you have to run in your cluster at the first boot. There are a couple of, as you may know, like Kubernetes use custom resource definition to make like external provider to contribute to a native workflow. And Cluster API is just a bunch of custom resource definition plus controllers that listen to those resources and take action on them. But how you can have a so flexible environment that gives you the opportunity to spin up clusters on Azure or on Packet or on AWS, even if the concept behind those cloud providers are different, because Packet doesn't have availability groups, regions or whatever. Every cluster is its own. So the cluster one is like the default one provided by Cluster API. Every cluster API. Yeah.
Would you mind making your font just maybe 1 or 2 sizes bigger?
Yeah, sure.
Okay, I think that should be good. Thanks.
Thank you. So the cluster is the resource that Cluster API provides by its own. And every cloud provider implementation has its own concrete implementation that usually is called like cloud provider plus cluster. So in my case, it's packet cluster. And there is also a concept of machine. And as you can see, it works the same way. There is one that is owned by the Cluster API and one that is owned by the concrete provider. So we have the machine and we have the packet machine. And as you can see, the packet machines has the specification that is per cloud provider. So we have the host name, we have the facility, we have the billing cycle. That is the way you get charged on packet, and there is the SSH keys. AWS has security groups, user data, and all these other stuff that you usually get from AWS. And there are also other concepts like machine deployments that they work a lot like deployments in Kubernetes, but they don't deploy pods, they deploy machines. And in this way, you can balance the amount of machines that you have. And as I said, I mean, all of those stuff are, custom resource definition. And you don't have to implement the cluster or the machine. You have to implement only the one that you need as cloud provider. So in my case, in our case, we implemented the packet machine, the packet cluster, and the packet machine template. That is just a way that you specify how your machine looks like, and the Cluster API takes care of creating them and to replicate them and keep them the same amount. So this is a very standard repository. We decided to take this approach because if you learn a little bit the foldering of one project, you can go in the other cloud providers and just figure it out by yourself how the other one works. So I hope it will help people to contribute to those as well. And as you can see here, there are the controllers. So if you remember how custom resource definition and everything else works in Kubernetes, you define a custom resource definition that is like a resource. It doesn't do anything. It's just the specification of the object, and you need to animate that in some way with a controller. And the controller is just a reconciliation loop. So it's a for that goes over and over until you say, I'm done. I say I'm done for the machine, for example, when the machine is running on packet. So this is the reconciliation loop for the machine itself. It has the client for packet, so the Azure has its own SDK, and as you can see, the code is not like that weird. It's also well contained on the reconciliation function. The reconciliation gets calls over and over until you say, I'm done, or wait for another 10 minutes because I'm not done yet. Because as you realize, cloud providers are not, are super reliable, but they may be slow, or they may not available in the resource that you need at the time you need them, because maybe you reach the limit, or maybe because they're not available. So the concept of reconciliation really applies well for those resources, because you never know if you are done until you're done. So you just wait and try and reconcile. So as you can see, like I get a bunch of stuff from the object itself, so specifically the YAML that we saw before. And at some point here, I create the actual machine on packet itself. So this is the function that pass the machine to the packet client, and the packet client calls the packet API that gives you a server. So there is also the delete reconciliation, because when you delete a machine, it doesn't get deleted like straight away. We store in events, and then there is a loop that goes over and try to delete the resource. So other than the machine controller, there is also the cluster controller, and the cluster is one that gives you the overall status of all the machines that you have in your cluster. So in this case, what usually a cluster reconciliation does, it gives you an IPs, and based on your cloud provider, it may be different. Usually it creates a load balancer in the cloud provider, and it takes the IPs or a floating IP or an elastic IP, whatever you call it, and it stores the IPs into the cluster specification. because that IP is the one that from the kubectl you will use to reach the end cluster. The cluster API goes and does all its workflow, so it creates the machines, and when the master is ready, the cluster API creates a secret that is called kubeconfig, and this is the one that you can download and use in your kubectl. So, and the cool part about this is that everything is like programmatically done. So you have code that you can check, and you can, there are annotation, for example, that you can place into the cluster specification itself to pose the reconciliation. So if you have a machine that for some reason doesn't need to be reconciled because it has issues and you have to wait and troubleshoot it, you can annotate that and it will stop. The reconcile will just skip and go over the next one until it's ready, and you can delete the annotation and the control loop will take place again. What's cool about the cluster API is also that it gives you a very, its own end-to-end test suite. So you don't have to write tests for the most common implementation. At Packet, we didn't implement it yet, or at least not a lot of them, because they use like Jinko, that is like a DDD like framework, and we didn't implement it yet because we do not support like multi-master. We are working on it right now. There is an issue for that, and all the test assumes that you can run like a multi-master and that you need an IP for that. So that's why we didn't implement it yet, but it will come. I'm sure that will come. Another cool stuff about the cluster API is the fact that you have one API, one cluster CTL that you can use for every cloud provider. And this is because like the provider itself is capable of packaging its own needs, and those needs get installed in the father of all the cluster API created clusters. And this is made like it installs a manager that is capable of like waiting for the request for the kubectl apply or the of the specification. And I think I'm done. As I say, the foldering is that one. So pick the one you for the provider that you like most, and have a look at it and see if you can use it. I know that there are people or companies that are implementing their own one, even if there is one for the cloud provider, because they have different needs, and maybe how do you provision a cluster can be way different. But the cluster API gives you a framework that makes it standard and reliable, and it also benefits for the community. So I'm done. Thank you for listening to me.